Hey, hello everyone. I hope you're doing well. Start by getting logged into Clever so we can get rolling. So, where's your tank at today? How are we feeling? Where are you at? Are you empty, full, somewhere in between? Tell me, how's your tank doing today? So, welcome to lesson 30. Today, we're going to be diving into valence electrons and particularly this idea of how we can visualize them. So, some reminders. As always, check assignments for grades and comments. I do a lot of my grading on Sundays and Mondays, and that's when you'll kind of see a lot of things being updated. So, if you do something after that because you kind of got a notification that, oh, I didn't turn this in, I will get to it. Don't worry. Just be aware that that's kind of the schedule that I follow. Make sure that you're doing the ed puzzles. Do not skip out on them. A, because half of them are real easy points, and B, the other half are super important for your being able to get the content. Remember, it is really important to try and come to the live class. If it doesn't work for you, those recorded versions are there. It's what you're watching right now. But like today's lesson, it was really great in how we were able to do it in class, and it's just a little bit different from how we're doing it here in this recorded version. So do what you can, do what works for you. Remember our expectations. Remember, there are resources. So when we take quizzes or when we do assignments, use your periodic table, use your assignments, use the lessons to help you out. The other big thing that we need to talk about is your makeup work. So we have 3 weeks until the end of the semester, this full week, and then 2 weeks when we get back from break. I need to have all makeup work in by January 10th. That is not the end of the semester, but I need to give myself that whole week to get your grades totally updated and have all of those things graded. So please make sure that you are getting your makeup work in. You can turn any single assignment in and it will be counted or graded without any sort of deduction. So if you're not happy with your grade, go and do your makeup work and you can bring your grade up. This week, we don't really have a ton of new assignments. And then you have 2 weeks over break when you're like bored and need to get away from your family. Go and do your makeup work and chip away little by little. Work week by week, watch the recorded lessons. And then do the assignments that go with the recorded lesson, and you'll kind of chip away little bit by little bit. Okay, don't give up. You can bring your grade up and get it to whatever you want it to be. So this week we're talking, as I said, about valence electrons, specifically these things called Lewis structures. That's kind of what we're diving into today. There's only 3 new assignments this week. The preview, which I hope you've already watched, a Lewis dot diagram practice that I'll explain at the end of class, and then a check for understanding quiz. It is going to be a little bit longer than our usual weekly ones because we've actually not had one in like 3 weeks. So kind of a lot to cover. And then the last thing I have highlighted on here, it's not an assignment, but do your makeup work. Remember, we are on lesson 30 here, so after this lesson, you should be able to do assignment number 70. So first, an important piece is to have a periodic table open. I say that every single week in every single lesson, but it's especially important for your warm-up and the assignment or activity that we're doing during class. So have the periodic table open in another tab. All right, so your warm-up is going to be to tell me how many valence electrons each of these 6 elements have. Remembering that the column on the periodic table tells you how many valence electrons something has. The columns go 1, 2, we skip all of the middle transition metals, 3, 4, 5, 6, 7, 8. So check what column each of these are in, and then tell me how many valence electrons they have based on that. Great. So let's check our answers. Xenon is over in the far right column, so it has 8. Carbon is in column 4, so it has 4. Germanium is below it, so it also has 4. Remember, everything in a similar column has the same number of valence electrons. Bismuth is 1 to the right and 1 more column to the right, so it's in 5. Strontium is all the way over on the left side of the periodic table. In the alkaline earth metals, it has 2. And then Sb, antimony, is right above bismuth, so it has 5 valence electrons. So these valence electrons are important for a couple of reasons. So first of all, remember, those are the electrons that are in the outermost shell. So if we're looking at the Bohr model, they're the ones that are on the very outside. The ones in the inside of those shells are all filled up. But the outside ones, those are important because they're the ones that are out and open to the world to bond and interact with other things. That's kind of what makes them the most important electrons, and it's why they have, or that's what kind of determines the properties. So remember that the column number tells you the number of valence electrons, and that all of the elements in that column have the same number of valence electrons. We also know that they have similar bonding properties as well as just general characteristics, and that's because of the valence electrons. These guys are so important, especially for what we're going to be doing when we get back from break. So again, remembering this setup, first column, second column, skip all these because they are weird. 3, 4, 5, 6, 7, and 8. So if we were in class, we'd do this in some small group work, but you're going to do this independently. So what's going to happen right now, we're going to look at 3 cards. Okay, each of these cards are going to give you some clues about these things called Lewis structures, which by the end of the class, hopefully we're going to know how to draw. So you're going to go and you are going to look at each of these cards one at a time, and you're going to determine what the card tells us about how to draw a Lewis structure. Okay? So here's our first card. What does this tell us about a Lewis dot diagram? Noticing the checks, those mean that these are the correct way to draw a Lewis diagram. These are the incorrect way to draw a Lewis dot diagram. So what do you think this means? All right, so here's some hints that maybe help you think about it. How do these compare to the elements on the periodic table? What about the Bohr models? What do you think valence electrons have to do with it? Okay, next one. This is card number 2. So remember, these are correct Lewis dot diagrams. These are incorrect Lewis dot diagrams. So what conclusion or what information do you think you can draw from this card number 2? Awesome. Thinking about how they're arranged. All right, so card number 3. What does this tell us about a Lewis diagram? Again, these 4 are correct. These 4 are incorrect. All right, so I hope that you kind of came to these conclusions. So the first card told us that the dots represent the valence electrons. So if we go back to this first card, okay, these are the correct ones, these are the incorrect ones. These show the number, should have dots for each of the total electrons that the element has. So sodium has 11 total electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11 are represented here, but that's not how we draw a Lewis structure. The Lewis structure, this one, it has 1 dot. And if we know that sodium Na is in the first column, that means it has 1 valence electron, and that's what's represented here. We can check this with beryllium. Beryllium is in the second column. It has 4 total electrons. So it is incorrect down here with its full 4 total electrons being drawn, but it's correct with its 2 valence electrons being drawn. I don't even know how many gallium has, but it has a lot. It is correct, though, because it is in the third column and has 1, 2, 3 valence electrons. Carbon, same idea. It's in the fourth column with 4 valence electrons and 6 total electrons. But this one isn't right, and this one is. All right, the next thing we learned is that the electrons go on the 4 sides in 2s. So looking here, there's 4 sides, top, right, bottom, left, and the electrons all go in pairs. You can't put more than 2 on a side. So we see that the 4 sides were kind of represented here, but you can't have 3, you can't have 4, you can't have 8 on a side, okay? The last piece of this is that the electrons have to be put one on each side before they get paired up. And so this, I like this imagery drawing out and showing the numbers of where the electrons should be placed and in what order. So seeing here again, carbon, we've already determined it does have 4 valence electrons, so that's right in that it has 4 valence electrons, but they can't be paired up until there's 1 on each side. So 1, 2, 3, 4. Okay, that's why this one's incorrect. Down here with oxygen, it does have 6, but how it's drawn here, there's not 1 on each side before pairing them up. So 1, 2, 3, 4, 5, 6. All right, we see that? Again, same idea with this magnesium and same idea with this arsenic. So our 3 big ideas, the dots represent valence electrons. The electrons go on our 4 sides, top, right, bottom, left. You have to put 1 on each side before you pair them up. Okay? So let's try this now. How many valence electrons does this have? And then how many dots are you going to draw and where are you going to draw them? So here is what the Lewis dot will show. This is kind of hard for us to practice in an Edpuzzle, but we'll give it our best. So potassium, it has one valence electron because it's in the first column, so it has one dot at the top. Boron, okay. Let's try this one. Boron, how many valence electrons? So what column is it in? And then how are the dots going to be drawn? So boron has 3 valence electrons. It's in the third column. You have 1, 2, 3 that are drawn. So 1, 2, 3. This is the correct version. You have to have 1 on each side before they get paired. Argon, let's try this one. So argon is in column number 8, so it has 8 valence electrons. You have them paired in 2s on all 4 sides because there are 8. That's the max you can have. All right, last one, tellurium, Te. Te has 6 valence electrons. 1, 2, 3, 4, 5, 6, 1 on each side before you pair them up. Good job. All right, so the good news is that you're going to get some practice with this with assignment number 70. That's the only assignment that you have for today. So I'm going to take us to that assignment really quick to walk you through what that's going to look like. So what it will look like is you will have a document. This looks very much like the Bohr model practice that we did, but the instructions suggesting to have a periodic table open, finding the column number to tell you the valence electrons, and then copy and pasting Control-C, Control-V, the dots to, and then following the rules to place them. Again, reminding you about those rules about where they get placed. So with lithium, we know lithium is in column 1, so it has 1 valence electron. And then again, we do Control-C, or you can right-click, copy, and then right-click, paste, and move that over. If it only has 1, it can go right here at the top all by itself. And that's it. Okay, there are 5 examples that you're going to try on your own. All right, so that is the last piece of today's lesson. If you have any questions, please don't be afraid to reach out, and good luck trying to do, or good luck with these Lewis structures. We'll practice more next time. See you then.